morning. I'm Eric Jacobson, Business Growth Specialist with iConnection. We're a digital marketing agency that specializes in website design and website marketing for manufacturers. I'm also the founder of Manufacturer Insights. And I'm very pleased this morning to have Scott Siegel, who's the Vice President of Products, and Jim Williams, who's the Vice President of Sales and Marketing for Kirk Rudy. And I met these gentlemen as well as Caroline Kirk, who's the owner and CEO of Kirk Rudy. We met at the Philadelphia Pack East Expo show within the last couple of months. And I was aware of Kirk Rudy from my days in the direct mail and fulfillment world. Kirk Rudy has always had a great reputation for building really solid, reliable equipment. And I know them from printing machines and other types of machines that would be used in direct mail. And I found out when I was at the show that they now have the capability of RFID. And we're going to talk today about RFID, but before we get into that, I just want to give Scott and Jim a chance to introduce themselves. So why don't we start with you, Jim?
Sure. Yeah. So I've been with Kirk Rudy for 9 years, started as an inside sales position in customer service, and really have a unique perspective to see this company that really makes every piece of our equipment from the ground up. We have a one manufacturing facility 30 miles north of Atlanta, and we build all of our machinery right here. It's the American made story. So it was very attractive to me to work here and to see how that we develop as the circumstances and manufacturing times change. We have a full staff of engineers, one of which Scott is the lead of our engineering department. And it was pretty interesting to see that we, as a former printer, I used to own an offset printing company back in the day, to see a company that will morph with the trends and demands. We are really great specialists at moving flat products extremely fast. So that's how we got our start in the mail business, because you want to move a lot of mail pieces very fast. And then with the mail business, we designed labeling equipment, and we can label things at top speed. And so then naturally, didn't take us too long to realize the need how we could participate in the RFID world, because we can move flat products such as a blister card or a flat box, and we can apply labels at very fast speeds. So soon realized that this was a no-brainer to go into the RFID technology. So that's why we are in this realm today. And you'll see as Scott continues to talk about what we have to offer, this is an industry that will have profound effects on manufacturers and consumers and the like in the future.
I forgot to mention, so Kirk Rudy was started in 1967 and is not only focused products made in America, it's a third generation company, which I find personally very exciting. I love to hear of third generation companies. So Scott, tell us a little bit about yourself.
So I'm VP of product here, been here just under a year. I'm loving it. It's an incredible company. We have so many people who've been here for decades. The product is well proven. It is awesome to see that there's so many machines just still out there from the 70s. RFID is particularly interesting. It is coming to America very quickly. It's been around for quite a while globally, and we're happy to be part of doing high-speed RFID label application and encoding.
So let's start with a little introduction. So RFID, radio frequency identification. What is that?
The vast majority of how people will interact with it is UHF, ultra high frequency. It's also known as passive tags. So there's no battery on them. The reader or encoder actually powers it up through radio waves to an antenna. So a lot of people have seen an RFID inlay, and they're decent sized, and most of it is just wiring. The chip itself is the size of a grain of sand. And the chip, the IC, is like a USB drive. It has a certain amount of memory. You can write things to it. You can lock it. You can password protect it. You can permalock it where it absolutely can never be changed. And you can read things from it. And that's really what it does. You power it up, read information from it, put information on it, and then in the future, other readers can read that information.
What's the typical range of that? So how far away can you be in order to read that information?
So it varies wildly on the type of label and what you're using to read it. Some readers are intentionally where you need to be close so that they don't get a lot of interference. Others, it's well over 30 feet. We've seen readers that can do 60 feet. Even the tags of a lot of highway, like tollway passes that are people mount to their windshields, a lot of those are passive. So those are being read at even up to 80 feet. So with the right label and the right reader, you can read it quite a distance. And on the other end of that, when we encode, because we don't want to encode more than one at a time, we really want a very small window, a bubble even, of where we're encoding. So it can range from something very small to something very far.
As I understand it, the advantage of RFID is each of those chips is transmitting a unique code to that specific item that's it's attached to. Is that correct?
Yes. When the inlays are made, they actually have a unique code on them that they call a TID, and TID, you'll hear it called. And so that's initially, everyone in the world has a unique TID. In general, when we put information on them, wouldn't even say in general, sometimes we keep it unique, like an individual serialization or a timestamp or something like that. Sometimes we're writing the same thing to all of them because people want it to work just like a SKU, like a barcode. The barcode on all those boxes is the same. So we can do that. Usually that would be to one section of the memory. So if somebody wants to use it like a barcode, however many digits it is, 96-bit, whatever, we'll write the same thing to all of those. And the cool thing is that if you have an entire crate full of them and you pass it through a gate, you can read tens of thousands of these tags basically at the same time. So you don't have to rely on optically scanning individual things. You can just pass whatever container through it with just about however many of these tags in it that you want and capture that all of those things were in this place at this time.
That's great. Speaking of engineering, I was looking at your website. I read some of the testimonials and some of the problem solving that you do and the types of applications where maybe you've helped out a customer. Jim, could you speak to maybe some case studies?
Yeah, not to take up too much time, but the most profound impact that recently happened by a customer of ours was over in the UK. This was a wholesale flower distributor. They go to Costa Rica. They have plants or farms in Costa Rica, and they bring the flowers over. And these are flowers that are sold through grocery stores, very much like we do here in the US. Grocery store flowers, we call them, right? And in the UK, that's also a very big business. And this particular manufacturer, this particular wholesaler, was really experiencing significant lost revenue because they had paperwork on the flowers. They had the flowers are all in boxes, and the boxes are put on a pallet. They're put in a truck, and they would have an order that says there's 100 boxes here going to J&J Grocery down the road. And Jay gets it in, and when it was time to pay the bill, or for whatever reason, they're like, no, I didn't get 100 boxes. I only got 80, and they wouldn't pay the bill. And this was happening over and over again. There was no proof of tracking. They tried the barcodes, so forth, and scanning, but it took significant time because, as Scott said, you were talking pallets and pallets of flowers. So what we were able to do is we were able to take whenever they have like a work order, it becomes on a sheet, and on the sheet becomes a label that will go on each box with a barcode. And through our high-speed applicators, we were able to take those sheets, run them through, put the RFID label chip on it, and encode the data, read the data from that barcode, and encode that data on that chip. So now they had a label that they're going to put on that box that had the barcode for those that needed to scan it on the other end. But it also had that very important RFID chip that did that. And then from there, they would load it on the pallet. And right as it's going into the truck, they had this giant reader that read everything that was on that pallet, all the item numbers and barcodes. So now they had a data, and they had a report that they indeed sent to the receiver, the grocery store. And it clearly says you have this many, And it's really undisputable because at that point, it's all logged through RFID technology. And immediately, and they needed this whole system implemented for their, if you can imagine what the busiest flower season might be, and that would be Valentine's Day. And then followed by Mother's Day, which is soon to come. So we just checked in recently with them, and they're ready to order a second system and have realized that this is the technology that they needed all along. The days of scanning and the labor, as much as that's a wonderful system for capturing data, very heavily labor intensive because you have to physically scan it. And there's human error, lots of human error possibilities there. So once they realized the value and the practicality of automatic RFID encoding and reading this thing and providing these data as a report, it was overwhelming. So they're super ecstatic. It was a great success story, and we expect many applications like that. It's just one example of the power of RFID.
So not just keeping track of maybe boxes and shipments, but shrinkage has become such a major issue. We see articles about that all the time. And I can imagine RFID chips being able to help in that area.
Yeah, and I'm sure that's why many of our major retailers here in the U.S. have actually mandated that RFID chips be put in their products. And again, we're very much experts at moving flat products and putting the RFID chips in it. Anything that is a blister card pack that's hanging on a pegboard in a store, lots of your office supplies and those sort of things are very easy in reality to put an RFID chip on there. And that helps tremendously. It's twofold. It helps the inventory. Can you picture that as a person takes a pack of pens off of the pegboard shelf and puts it in their shopping cart? Immediately a signal goes up to the ceiling and notifies the back end, the warehouse. That night, they're going to have to restock that pen and multiple others. And then, of course, it's carried throughout the store, and it gives them real-time data when they do a final checkout of how long that shopper was in the store. So there's so much data that an RFID can give a business and a manufacturer, especially if you're tagging parts throughout a manufacturing warehouse. And how long has that part been in there? Has that part been used and so forth? So really, Eric, it blows your mind when you think of the possibilities with having that data. And we all know that in business, data is key.
So the last time we spoke, we talked about something called ARC certification. And you had mentioned an application, a company that you've been working with who now has ARC certification as a requirement for vendors working with them. First of all, what is ARC certification? Tell me a little bit what that's about and what the implication is for companies that may be providing product to, in this case, we were talking about the retail space.
ARC is actually the Auburn RFID conference. So Auburn University over in Alabama, they were tapped by some of the world's largest retailers to be the authority over certifying. Initially, it was that the labels themselves were capable of reliable scanning. So fortunately, these retailers, I think it was a very smart move, used this university to handle that, to develop what are the specs for the actual inlays that go on products, because different products really require different things depending on how radio transparent or reflective or just how much interference they create if there's metal or liquid involved. So there's a big list of specs created by ARC, and they have different inlays. So in many cases, there's 20 or 30 different inlays that are all certified for that spec. And one of the changes, I was actually just at Auburn about 2 weeks ago at the RFID workshop, and they were going over some of the changes that are coming this year, where it's not just the inlay. So today the specs, if it's a hang tag for pens, or if it's for paper goods, or jackets, clothes, shoes, batteries, tires, so those all have different types of specs in order to make sure that those RFID labels can be read when they're in a pile of the same kind of thing. This year, one of the changes coming is that the actual packaging itself needs to be certified to make sure that it's all well and good for one tag to be certified, but if you have it on a shelf, they need to be able to read it efficiently. So that's, ARC is, like I said, it's the Auburn RFID conference, and their certification is just to make sure that manufacturers know how to, like, what labels to use, how to apply them, where to position them, so that these retailers can utilize the RFID technology efficiently.
So would it be accurate to say that your machinery helps manufacturers to become ARC certified as they're delivering product to, say, a retailer?
Yes, thank you. So how are we involved? We're a solutions provider. So there are a lot of manufacturers that sometimes it's where they get their boxes made or where they get the backing, the hang tag made for it. So they can work with their packaging providers in order to often use our machines to apply the right RFID labels, to encode them, to print on them or to print near them. And we do it at very high speed. So for large volume manufacturers that are putting a lot of products into these retailers that require it, often it is our machines that are actually applying the labels and coding them as required, possibly printing on them, verifying that the right information's on there. And now we can even verify it to make sure that the performance of the label is appropriate.
Yeah, I'm just wondering here, what's a kind of an average throughput on your machines for applying an RFID tag?
That's a great question. That is one of the main things about Kirk Rudy is we do stuff fast. We do stuff for production at high volume, places that in a lot of cases run 24/7. Just applying the labels. So applying the labels is often done at about 300 feet a minute. We have some that will apply it at 400 feet a minute. We've got a lot of things coming where we can go even faster. We've got a system right now that we have successfully applied at almost 600 feet a minute. And we can also read, encode, and verify at 600 feet a minute. At the RFID show last week in Las Vegas, we were actually there with a demo, actively running over 600 feet a minute, and passing by a single head, we were reading what the tag was, encoding what we wanted on it, and then verifying to make sure that it would read what we wanted it to read. And we can do all of that over 600 feet a minute, which in most cases is well over 40,000 pieces an hour. In some cases, it's over 50,000 pieces an hour. In theory, our system can do 70, but that's a theoretical max, depending on the product size and spacing. But realistically, well into the 50,000 pieces per hour can be done with high-speed transport and high-speed encoding.
That's really impressive. Yeah.
It's fast. It's hard to see fast.
So we already talked about some of the benefits of RFID, the inventory management and shrinkage type of assistance that it can provide. What are some of the other benefits of incorporating RFID into the manufacturing process?
So in the manufacturing process itself, the great thing is you can see where everything is live all the time. In some cases, there are companies that put it on equipment, even in some cases down to individual tools. And by having readers often in the ceiling, but that can triangulate, they can actually see where everything is live. It's not manufacturing this particular example, but there's a retailer that has a grid of readers in the ceiling, and you can actually ask any of the associates there if the certain product in a certain size is available, and they can pull it up on a tablet and show you exactly where in the store it is. And if it's in somebody's cart, it's moving. But the great thing about that is if something hasn't gotten put back in the right place, they can see exactly where it is. The same thing works in manufacturing, is there's never a question of where is this item, because you can see often it's just laid over a blueprint. You can see exactly where something is. At the very least, if you have several gates, you can see when it's moved from one area to another. And I would say that's probably how most of what we've seen being used in manufacturing is that it gets applied to a bin or a package or a product. And when it goes through a gate, they get the timestamp of that one or that 1,000 pieces all went from this area to that area on this day at this time, and they can see it. And they can tell that it hasn't left. If it goes into a certain area in a warehouse, with all of the exits to that are covered with RFID readers or gates, then you know that it's still there somewhere. And you can, a lot of the readers, you can walk around, you can adjust how far they're reading, and you can know when you get there. A really cool piece of technology, I haven't seen it implemented yet, but I'm excited to, that we saw just last week was Readers, so inlays that have LEDs in them that are still passive. There's no battery. They're powered by the reader, but the reader can specify any one or group of RFID labels to light up the LEDs on. So if you had these all visible somewhere, you could point the reader at it, and if you wanted to light one of those up, it would light that one up and you could go pick it. In manufacturing, that could be used if you want to label a whole rack of part bins, and you just stick these labels on all of them, and you have a reader that can tell that operator which bin to pick from. You can do that without wiring that rack of bins. Or if the bins come with the product, and some assembly lines that I've seen, you'll have something that you're working on and the parts that are associated with it. Those parts are in trays that have these labels on them. When they get there, the reader could literally light up, this is the first part, this is the second part. So it's the technology, the functions that RFID can do in manufacturing in real use are expanding quickly, and it's exciting to be part of that.
So one of the things that I hear a lot about, it's the big buzz phrase right now, is manufacturing 4.0. I hear it at trade shows. Industry Week has articles on it. And it's about, or I want to ask, what is the role of RFID in manufacturing 4.0 in improving operational excellence, those kinds of things as it relates to manufacturing process?
So in addition to giving you all of the automatic time studies and movement, because when something got started or when a tag started in the system, it's start of life. And if it has an expiration or it has PM requirements, then you'll know. It's very easy to know when that went into the shop or when something is needed. And actually, one of the things I learned about at Auburn a couple weeks ago was that a lot of the airlines, not a lot, all airlines have safety requirements, and they must verify that the correct safety equipment that's up to date is on the plane before each flight. So it used to be that they would go in and just visually look, then obviously they got to the point where they could scan. Now it's RFID. So before RFID, it took over 20 minutes to verify all of the required safety equipment on a typical passenger flight. Now it takes 2. So not only are they verifying that it's there, but because it has a unique serial number, they know that it's in date, and they can have automatic pop-up warnings that say this piece of safety equipment is going to expire in the next 2 weeks. This plane needs to have that swapped out before then. So not only in factories where you see the lifespan or timelines of everything, but even other uses in the real world where you really need to know, is it there? How long has it been there? Do I need to do something to it again?
I would imagine, as you were talking about the traceability of, parts and things throughout the plant, and even in the retail, I would imagine that would play a role in customer service by having that real-time data of where something may be in a retail store or in a manufacturing facility.
Yes, my family raves about it. There's certain retailers that are already using it where they have a grid generally in the ceiling of readers. There's RFID tags on all of the products in that particular store. And if they're looking for an item in a size, any of those associates can pull it up on a tablet and see exactly where, if there's only one left, where that one is. If it's in somebody's cart, they can see it moving. But if it's been taken out and put somewhere else, they can see exactly where in the store that is. And that ability to just know where something is without being able to see it is incredible, whether it's in retail or manufacturing or hospitals, anywhere else. It really is amazing to be able to know where your stuff is.
Scott, when we hear about RFID, one of the things I always think about, I'd like to travel internationally, and you hear about people who will steal credit card data that may be encoded on an RFID tag, so on their credit card. So could you talk about RFID tags and security? What are some considerations that people need to be thinking about that may not be on their radar?
So credit cards specifically actually use NFC, near field communication. So it's a HF chip, not a UHF chip. So their ultimate distance range, even on their own, best case, sitting out on a table, the range is still much shorter. Could somebody with a reader get close to you and read an unprotected card? Absolutely. The RFID protecting wallets and sleeves and things are absolutely legit. They work perfectly well, which is good and bad. If you have a card in there or any type of RFID label, it cannot be read through those. They just reflect all the RF signal. Because remember, they're all passive. There's no battery on them. They have to be powered by enough radio power getting to them to power that chip up to even read it. And the thinnest of metallic sleeves will stop even a lab grade reader from reading a label that's inside one of those sleeves. If it's something you're concerned about, it is very easy to really completely prevent anything from reading anything in that sleeve or that's protected. Security in general with RFID. So again, it's like a USB drive, and like many USB drives, you can password protect it. So you can write information to it and say, without this password, you can't unlock it. You can't change any of the information on here unless you have this password. And because inherently they are easily rewritable. Like when we're testing machines, we don't throw stuff out. We have a big stack of test material and it runs through over and over and over, which is great for testing. In a manufacturing use, if you want your bins labeled, but you want to restart that bin numbering either each day or each set or whatever it is, you can just rewrite what's on the tag that's on that bin. You can have them permanently labeled and your database can control it. But if you want to change them, it's super easy to do. The other end of the spectrum is a permalock. A lot of the retailers have understandably insisted that for RFID to be used in their store, in their system, they have to be permalocked. And permalock is, to my understanding, a legit permanent lock. Nothing you do can rewrite the information on that tag. So nobody's going to be able to walk into a store and have an encoder or an antenna and take something expensive and write an inexpensive price to that RFID tag. Permalock means they are unrewritable permanently.
Scott, tell me a little bit about what does it take for a manufacturer, so someone who's not just applying RFID to packaging that's then going to go somewhere else, but if they're actually using RFID in their operations to improve their operations, that operational excellence, manufacturing 4.0, what does it take to get up and running, to implement the use of RFID tags?
I would say it runs the gambit. At its simplest, it's like a barcode that you don't have to visibly see, right? On that end, it's, if you already have a system, going from something optically read to RFID is very easy and can even be done inexpensively. On the other end, to use it to really the fullest of its capabilities, it could be extensive. You may want to cover a lot of the plant or at least certain areas or entryways and exits with readers that are capable of reading at a distance. You need to have an appropriate kind of packaging scheme. So in manufacturing, there's often a lot of metal. And with that, if you have components that are in something metal, often you'll accumulate. So you may have several RFID tags on things that go in, whether it's in a vehicle or it's in something in the plant that you're not going to be able to easily read through. And then you'll put another one on the outside that is easily read through, and you just know you can even scan it. These 10 things are in this one. And it's easy for you to see where the big one is, and the system knows what's inside it. What I've seen in manufacturing is often if something is going to leave and come back, and you need to re-verify that it's the same pieces in there, and or something that comes in new to that area, and you need to know how old are the things in it. And it's easy to see, even for the first time that it's visited there, you can scan everything. It'll still obviously have to look it up in the system. That said, we've had more people so we don't always know exactly how everybody's using our stuff. Thinking back on some recent conversations, people have been, so they can write whatever they want to each tag, right? We just help them, our machines help them do it. We help get the tags on there, we help them interface with their own software and code, etc. How they make their database, what they're writing to it, can include the timestamp in it. So you could have something that arrives, scan however many things that are in there and see what's the oldest thing in here. Or you can even know that it's identifiable. This type of part, you can put an expiration date on it. You could either know when it was encoded and know that by what it is, it's only good for this long. Or you could even write expiration dates into it, have something come into that area, get scanned, and you're like, oh, these 3 things are expired. You can utilize it because you can write anything you want there. You can say what it is, when it was put into use, or when it needs to come out of use. Using rewritable tags, you could always just update it. So if it's something that needs to be serviced, then you service it and you rewrite the tag to say, this is the new start date or the new expiration date. They're really only limited by how they want to use it. We've already talked about covering the whole warehouse or something with readers so you know where things are. But like you said, for manufacturing 4.0, the ability to put dates and product codes, things like that in there can really help with maintenance, making sure that you handle things before they're a problem.
So Scott, some of the things that you talked about, I know when we originally spoke before today, we talked about the packaging industry, laying down RFID chips on cards, just a very simple process. But I would imagine, just knowing the history of Kirk Rudy, that you get involved in much more complex types of feeding operations. And then you also mentioned IT and software. Maybe you could talk about an application that you've done that's more complex than just applying a chip, but then also maybe some verification practices that you've implemented in line.
Certainly. Yes, we do have a lot of applications that require 100% verification. We work with banking institutions all over the world. We work with other organizations that just really require 100% verification. Often our systems will feed product. It may read something from that product initially. It'll look things up in the database, which is obviously customer developed. Fortunately, we have our own software. Our own developers can work closely with customers and usually do. As soon as something needs any tweaking, that's just part of how we do it. So we can read it, whether it's a barcode, like a 1D or a 2D or OCR. We can read text very fast. I was impressed to find out it's about 8 milliseconds for us to read typical address and OCR. Then we can process that and determine, sometimes it's as simple as, was that good? Should we apply a label? And if not, we can divert it and not even waste the label. But generally, we'll be feeding, reading, applying something, encoding and verifying. So making sure that what's on there often will print either on the label itself. So sometimes you'll apply a label over a UPC and then you want to print either the same or an updated UPC on the label itself. And then often we need to verify. So often our last step is optical, because often there's a camera at the end, and RFID verification. So the last snapshot is, we know for sure that it was the right product that had the right printing on it and the right encoding. So that's pretty common to feed, read, apply, encode, print, and verify. And then obviously we offload, either conveyor, restack, whatever at the end. So there's a lot involved in properly labeling something.
That's a great example. I would imagine we have several customers that supply to the Department of Defense. I could definitely imagine an application for that. Manufacturing is all about accuracy, the whole track and trace. So I definitely see many applications for this. So excellent. As we wrap this up, I have one last question for you. Scott, are there particular types of products that labels are attached, the RFID labels are attached to, that present challenges when you're trying to read the tags?
Certainly. So to read through or around or on metals or liquids is more challenging. So there are a lot of solutions out there. In general, you could end up with a much more expensive tag if you have to be at the same level as liquid or obscured by a lot of metal. Alternatively, say you have a spray bottle that has a head sticking out and there's liquid on the bottom half. So just slapping a label on there would be a lot more challenging to read through the liquid of all of the other labels at the same level. But the head's all plastic. So we get the challenges of, can we get a label onto that head? Or how do we make sure we have a readable RFID tag on this product? And sometimes it's adding something that goes around the neck that just hangs off, or particularly small labels, or interestingly shaped labels. And then honestly, getting to figure out how to apply those at speed and volume is one of the fun challenges that we deal with here at Kirk Rudy. Shouldn't even say deal with. I really enjoy the continual influx of real engineering challenges that we deal with regularly. And having been at the Auburn event, I could see how many manufacturers needed a partner, a solutions partner. They said, we have this product. We know that we need to do these things in order to get it into these retailers. How do we do that? That's not their area of expertise. And fortunately, Auburn and other places are working hard to connect manufacturers with solutions providers for the betterment and opportunity of really RFID for everybody. So it was a great event. The competitors that were there still know that it's better for all of us to make sure that this technology works for all of us.
Quite fascinating at things like the trade shows, the expos, of manufacturers coming there to talk to vendors to try and identify, who is it that can help me solve this problem? And that's where, I'm sure you and your engineering team can come in and come up with potential solutions.
Yeah, it's super fun. It's always interesting to me to find out that companies that many people would think are competitors, maybe even competitors to us, they have Kirk Rudy bases in their labs. We regularly install their whatevers on top of our bases. So the whole industry, I'm really manufacturing as a whole, things like you yourself, all these opportunities to share best practices just for the betterment of all business and all manufacturing, to make things more efficient, more higher quality, more sustainable. This is the exciting stuff about the world, right?
Scott and Jim, I really want to thank you for joining us this morning, telling us about RFID. It was really informative.
Thank you so much for inviting us. This was great to do.
Yeah, absolutely. Thank you so much, Eric. We really appreciate that. We're so excited about the future with RFID.
I look forward to seeing you at the next manufacturer expo.
For sure.
Exactly.